The UK has just held a general election, and the opinion polls released prior to the election have raised a few interesting statistical issues. So, the day before the election was held, YouGov released a poll suggesting that the Conservatives were expected to get 34% of the vote, Labour 34%, UKIP 12%, the Lib Dems 9%, SNP 5%, and the Green Party 5%. Now, this is just a snapshot of public opinion, and it can be used as an estimator to give us an idea about how the population is going to vote. But the opinion poll companies came in for a lot of criticism after the election because when the actual results were seen, they looked a long way away from the results of the polls. So whilst the poll suggested that the Conservative Party were going to get 34%, the actual result gave them 36.9%. Similarly for Labour, the poll suggested they get about 34%, but in the results they got 30.4%. So if we observe an individual poll which has this big difference from the actual results, is this a problem? Is it a surprise that every so often we get polls which have a result which is a long way away from the true general election result? So let's try and examine why this sort of difference might occur. Well, one reason that this may occur is something called sampling variation. So let's have a look at what sampling variation means. So let's try and illustrate this by considering a population. And this population is made up of only Conservative voters or Labour voters. And they might be distributed in the population something like this. So there's a number of Labour voters, there's a number of Conservative voters, and in this population there are more Conservative voters than Labour voters. There's 59% of the voters are Conservatives and 41% of the voters are Labour voters. Now, what opinion poll companies do is they take a sample from the population. So let's see what happens if we just take a random sample from this population. Well, the first random sample that we might take might look something like this, where we have 50% of the voters are Conservative and 50% are Labour voters. So this first sample suggests that we'd expect 50% of people to vote Conservative, 50% of people to vote Labour. But remember, that's not quite the same as in the actual population. In the actual population, we had 59% voting Conservative, 41% voting Labour. So our first estimate, what a poller would say is, well, it looks like the vote share is roughly equal, but we have randomly sampled from the population. But let's see what happens if we take another random sample. Well, we could take a different random sample from the population, and in this case, we've got 80% Conservative and 20% Labour. So just by taking a different random sample, we get a different estimate of the voting share. And every time we take a different sample from the population, we'll get a different proportion of Conservative voters or Labour voters. And this is what is known as sampling variation. So just as a summary of the two samples that we've had, the first sample we had 50-50 split, the second we had 80% Conservative, 20% Labour. And as I say, this is what is known as sampling variation. Now, opinion poll companies don't just take 10 individuals. They tend to try and get a representative sample, and they consider a representative sample to be about 1,000 voters. But even with 1,000 voters, there's still going to be variations between samples. And YouGov have suggested that the margin of error around their polling results is about plus or minus 3%. This is essentially a 95% confidence interval on their results. So let's have another look at the poll results and compare it with the election results. Remember, there is a plus or minus 3% margin of error around these results. So even though we've got this poll suggesting 34% of people are going to vote Conservative, that could indicate anywhere between 31% and 37%. But when we look at the results, the actual general election result for the Conservative was 36.9%. So in other words, the poll was only 2.9% below. So that's within the margin of error. So just observing this poll, it doesn't look as if there's a particular problem. For Labour, it's a bit more of a problem in that the opinion poll was 3.6% above the true result. That's slightly outside of the margin of error, but it's still possible that you could get a 34% fraction due to rounding errors, due to just random variation. But all of the others, they're all within the margin of error. So just by looking at this single poll, we can't say that there's something wrong with opinion polls on the whole. But what we might really want to look at is whether or not there's some persistent bias to the results. So what bias is, remember, is that if on average the polls don't give the correct population parameter, so in other words, if on average the polls aren't representing the voting intention of the population, then we would say that there is bias. So let's look at what the opinion polls looked like between the 27th of April and the election. Well, the voting share between Conservative and Labour, it's fairly flat. It's fairly flat between about 33 and 35%. And if we plot on the actual vote shares at the election, for the Conservatives, it's up at the top, then below it's Labour. But what we see is that the Conservative vote is always, or the vote share indicated by the opinion poll is always below the actual vote share. And similarly for the Labour Party, their indicated vote based on the opinion poll is always above their actual vote share. So remember, an unbiased estimator is one that on average, as we take the average of a lot of different estimates, gives the correct sample or the correct population parameter. In this case, the average of the opinion polls for the Conservatives is always below the actual results, and the average of the opinion polls for Labour is always above the actual results for Labour. So what we have is that the polls give a biased estimate of the vote share for Conservative and Labour. For Conservative, it's a negative bias. It's always biased downwards because we're always underestimating the actual vote share. For Labour, it's biased upwards because we're always overestimating the actual vote share. Well, what would we expect opinion polls to look like? Would we expect it to always lie on the exactly on the actual vote share? Well, of course we wouldn't expect it always to lie on the actual vote share because of sampling variation. But in order to examine what it might look like, I've simulated some opinion polls. I've simulated opinion polls where I've randomly sampled 1,000 people with similar voting intentions as a population to the UK population at present. So here we can see our samples or our simulated samples of opinion polls. And the key thing here is that they are centred on the actual Conservative and Labour vote. If we were to look at more observations, we'd see that over time it would always be centred on the actual vote. If there's no bias, then that's exactly what we'd expect to see. We'd expect to see the polls to be centred on the actual value. So if we observe a lot of polls, we can get a much better indication of the overall vote share. But as we say, it looks like in this case, prior to the election, the opinion polls were biased. Now, what might be the cause of this bias? Well, one thing that might cause a bias is if the sample isn't random. So if the sample that they're taking from the population isn't random, it could cause bias. And the opinion poll companies recognise this. So what they do is, when they take their sample, they examine the sample and say, is this representative of the population as a whole? Is it roughly representative of the demographics in terms of age? Is it roughly representative in terms of the demographics of gender? Is it roughly representative in terms of the proportion who voted Conservative and Labour and Liberal Democrat at the last election? And if it isn't, what they do is they weight their data so that it's more representative of the population as a whole. So if they have an underrepresentation of, say, 18 to 25-year-olds, they place more weight on individuals that they observe between the 18 and 25 age group. So they try and weight their samples so that they don't get any sort of sampling bias. But is there anything else that might cause this bias? Well, there are several other things that might cause this bias, but one key thing that might cause this bias is the idea of people who don't know what they're going to vote for when they're polled. So suppose that we observe our population like this, and there is a sample of people who haven't made up their mind. Well, this doesn't matter if they have the same sort of voting intentions when they eventually vote as the population as a whole. So in other words, if the same proportion of the unknowns vote Conservative as in the population as a whole, and if the same proportion of Labour voters vote Labour as in the population as a whole. But the problem comes when we observe these undecided voters and, for instance, if all of them decide to vote Conservative. Well, if all of them decide to vote Conservative, then when we've observed the population, we will have underestimated the Conservative vote. Similarly, if all of them decide to vote Labour, we would have underestimated the Labour vote. But if they are just randomly choosing between Conservative and Labour according to the same probability in the population, then it wouldn't cause any bias at all. Thank you very much for watching, and goodbye.